In the shadows of Geneva, concealed far underneath the outer layer of the Earth, there lies a gleam of human capacity, a machine that might be the impetus for our catastrophe. The Large Hadron Collider, or LHC, is a beacon of scientific discovery that has enabled researchers to finally locate the enigmatic Higgs boson, also known as the God particle. As of late, nonetheless, this search instrument has turned into the focal point of consideration. Prestigious physicist Brian Cox, a powerful figure all through mainstream researchers, has put out an announcement that has sent shockwaves through the universe of science and then some. Something unnerving has been found at CERN which might be past our ongoing comprehension. Are we headed in the wrong direction because of our quest for knowledge? Prior to jumping into the subtleties of Cox's declaration, it is vital to comprehend what molecule gas pedals are and why the LHC is so significant. The Huge Hadron Collider, worked by CERN, is the biggest and most impressive atom smasher on the planet. This 17-mile ring of supercharged magnets addresses the apex of human logical accomplishment. Because it is so powerful, this machine can recreate the conditions that existed at the universe's birth. However, what if the key to something even more sinister lies within this machine, which was created to decode the deepest secrets of the world? Established in 1954, CERN is one of the world's driving examination associations, with 23 part nations and large number of researchers from around the globe cooperating to push the limits of our comprehension. Although the LHC is CERN's primary endeavor, it is only one component of a larger network of accelerators and experiments. Envision a course not really for vehicles or ponies, but rather for subatomic particles hustling through existence. The LHC speeds up protons to the speed of light and sends them on an impact course, impersonating the energy of the universe at the hour of the enormous detonation. These crashes make temperatures a large number of times more sultry than the sun's center, temperatures that stretch the boundaries of what we can make and control. The innovation required is astounding. Great many magnets guide the protons on their excursion, while complex cooling frameworks keep the magnets colder than space itself. The LHC's design is incredible. Two parallel beam lines are shielded from Earth radiation and located 574 feet below the surface. The entire system is cooled to -456.04 degrees Fahrenheit in this underground world. In the LHC, protons crash at 4 unmistakable areas around the gas pedal ring, relating to the areas of 4 molecule identifiers: Chartbook, CMS, ALICE, and LHCb. Every one of these identifiers has an exceptional reason and examines various parts of molecule material science. These high-energy collisions are captured by their grand camera. Researchers inspect the flotsam and jetsam from these crashes to search for indications of perplexing particles, for example, the Higgs boson, which are vital to understanding the structure blocks of the universe. Yet, with each answer comes another inquiry, and with each disclosure another test. In addition to serving as a scientific instrument, the LHC is also a symbol of human creativity and curiosity. It symbolizes our desire to comprehend the fundamental forces that shape our world and our pursuit of knowledge. Notwithstanding, pushing the limits of what we know likewise brings up moral issues. What is the gamble of obscure repercussions? Could we unconsciously unlock forces beyond our control by attempting to comprehend? A revelation that shakes even the most experienced scientists has surfaced within the confines of CERN, where human understanding's boundaries continue to shift. Brian Cox, a noticeable voice in the realm of molecule physical science, made a declaration that stunned and frightened a large number. Cox was clear when he said that the Large Hadron Collider at CERN aims to recreate a miniature Big Bang. Indeed, you heard that right, a little form of the rule that brought forth our reality. Cox went on to discuss the implications of this goal and the LHC's enormous potential for new discoveries, such as locating dark matter, a mysterious substance that makes up a significant portion of the universe, and deciphering the mysteries surrounding the Higgs boson. Envision grasping the force of creation, the capacity to see the pith of life. It's a tempting idea, but there are risks involved. Especially at the LHC, the mini Big Bang is not just a theory. The energy, temperature, and pressure levels are comparable to those in the early universe. It resembles remaining in the beginning of recorded history and seeing the introduction of your universe. In any case, with that power comes extraordinary obligation. This asks the central issue. Imagine a scenario in which something turns out badly. For sure, something turned out badly in 1978. Russian researcher Anatoly Borsuk encountered a mishap that changed his life until the end of time. During tasks at the U-70 synchrotron at the Foundation of High-Energy Physical Science in Protvino, Russia, a glitch caused a devastating mishap. A proton beam of unprecedented energy hit Borsuk. The pillar went through his skull, leaving through his nose. Astoundingly, Borsuk didn't experience quick lethal impacts yet got through extreme wounds. The bar caused nearby tissue demise, prompting hearing misfortune in one ear and loss of motion of one eye. He continued his scientific work despite these injuries, which preserved his intellectual capacity. Particle accelerators' enormous power and potential danger are illustrated by this incident. A machine like the LHC carries risks that should not be taken lightly. The potential for unconstrained responses and the control of substances in existence are not subjects of sci-fi but rather genuine worries communicated by some in mainstream researchers. One of the greatest worries about LHC tests is the likely production of a small dark opening. Space regions known as black holes contain energy that is so intense that light cannot escape. They are once in a while considered vast vacuum cleaners or star eaters. The possibility that the LHC could make such a peculiarity, even on an infinitesimal scale, is stunning to general society and specialists the same. Might this dark opening at any point develop wildly and swallow the Earth from the inside? As predicted by Stephen Hawking's theory of Hawking radiation, CERN scientists have publicly stated that a black hole would be unstable and disappear almost immediately. However, there is still controversy and fear. The power we use is vital to understanding how the LHC makes dark openings. The structure of spacetime is distorted when protons collide at nearly the speed of light, releasing a significant amount of energy. Consider a trampoline loosened up with a significant burden on it. The fabric stretches, and if the weight is sufficient, it can leave a deep indent that engulfs everything in its path. A metaphor for what takes place at the LHC is this. In the realm of quantum material science, the bizarre and lovely laws of the universe are remembered to conceal different aspects. The LHC could interact with these dimensions and create a tiny black hole if they exist. This secretive dance of particles has drawn in the consideration of a portion of the world's most popular researchers, including the late Stephen Selling. Hawking warned in his book A Brief History of Time that the Higgs boson might become unstable at higher energy levels. This insecurity could prompt a devastating vacuum breakdown, an occasion that could obliterate Earth as well as the whole universe. Sir Martin Rees, the famous English space expert and astrophysicist, has likewise communicated worries about the investigations led at CERN. Particle accelerator experiments, including those at CERN, were the subject of his book on the prospects for humanity's future. His words were set apart by dread, examining a most dire outcome imaginable where a terrible investigation could cause what is happening known as vulnerability. This could hypothetically modify the period of room and advancement the texture of room time, prompting a worldwide fiasco. Rees' interests were not restricted to hypothetical contemplations. He recognized the chance but little of unfortunate results, yet demanded that regardless of whether the odds were good that little, we ought to tread carefully. A lot is on the line, and the edge for blunder is thin. CERN researchers have determined the dangers, run reproductions, and inspected speculations to contend for the well-being of the LHC. Brian Cox himself grasps the significance of cautiousness, recognizing the worries encompassing LHC activities. He guaranteed the public that severe security measures are set up, with different controls and strategies to guarantee that LHC activities are directed with absolute attention to detail. Cox emphasized that the forces exerting influence on the Earth are erratic and have a very low likelihood of causing a catastrophe.